Alright, so let's go ahead and talk about series. Let's say we have the series going to 3, starting at 1. Starting at 1 on the bottom, stopping at 3 on the top of n. So what does this mean? This is asking us to evaluate the function when we plug in different values of n. And we're going to plug in a value into the function right here, and then add it to another function when we plug in the next number. We're going to increment it. So that's going to be 1 plus, plug in the next number, 2, plus the next number, 3. And we're stopping at 3, right? We evaluate this, and this gives us 6. So the answer for this one is going to be 6. So let's go ahead and make it a little bit more complicated here. Let's say we have the function n plus 1, starting at 1 going to 3. So we're going to do the same thing, 1 plus 1, then 2 plus 1, adding them together, plus 3 plus 1. I believe this evaluates to 9. 1 plus 1 is 2, 2 plus 3 is 5, 5 plus 4 is 9. So this evaluates to 9. So let's make it a little bit more spicy here. Let's say we have the series starting at 1, going to infinity. What will that look like? So we're going to do the same exact thing. 1 plus 1, plus 2 plus 1, plus 3 plus 1, plus 4 plus 1. And we're going to keep going until we have infinity plus 1. So you would imagine that this is going to be a very large number, such that it cannot be represented numerically, giving us infinity as the answer. So, as you can tell, when a series approaches infinity, and it doesn't go to a singular value, it just keeps going up forever, this is what we call divergence. Divergence means that it does not approach a singular value. It just keeps either changing or it goes on forever into infinity. So let's go ahead and do one more that's a little bit more spicy. And we're going to bring up our next concept. We have the series starting at 1 going to infinity of 1 over n squared. What will this look like? Will this also approach infinity? We're adding every single evaluation of this function for different terms of n, for different inputs of n. So we'll start with 1 over 1 squared, plus 1 over the next number, 2 squared, plus 1 over 3 squared, plus 1 over 4 squared, plus 1 over 5 squared, and then this will go on forever, and yeah. So as you can tell, 1 over 1 is 1, 1 over 2 squared is 1 over 4, plus 1 over 3 squared is 1 over 9, plus 1 over 4 squared is 1 over 16, 1 over 5 squared is 1 over 25. And as you can tell, this number is going to become increasingly smaller as time goes on. And what that means is that we're going to be adding numbers as the value of n grows larger. We're going to be adding numbers so incredibly small, they're going to grow so small that they're going to approach 0. That the number as a whole is going to approach 0. So there's going to come a point that we're going to be adding plus 0, right? Because what this means is that we're going to be, at some point, we're going to have 1 over infinity squared. 1 over infinity, if you divide anything by infinity, it's going to be 0. So, how can we tell without doing all that work? How can we know without writing out on and on and on forever, just to be certain that a series converges into a singular value or diverges into infinity? Because this is what we call convergence. Because as we just mentioned, the values that we're adding together, at some point, they're going to be so small, they grow smaller and smaller and smaller, that you're basically adding 0 to the sum. That's what we call convergence, when it converges to a singular value and it doesn't diverge into infinity. So another way, an easy way, and we can tell if a series converges or diverges, is by utilizing the p-series. The p-series says, if we have 1 over n to the p power, when p is greater than 1, the series converges. Because as you have numbers larger than 1 for p, the series, you're going to be adding numbers small, it's going to approach 0. You're going to be adding 0. However, when p is less than or equal to 1, the series diverges. Okay? And we could utilize this because it saves us so much work. We're not going to have to add 1 plus 2 plus 3 plus 4 plus 5, blah, 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 blah. It saves us a tremendous amount of time, and we're able to make more advanced calculations in a shorter span of time.